We now determine the increasing intervals, decreasing intervals, and relative maxima and relative minima of this function f of x equals 2x squared minus 8x power 4. So first, let's determine the increasing and decreasing intervals. For that, we have to first determine the critical points. So critical point occurs when f prime of x equals 0, that is when the first derivative equals 0. So let's find the first derivative of this function by differentiating both sides with respect to x. So we get f prime of x, and this equals the derivative of 2x squared. We put the constant 2, and derivative of x squared is 2x. We then have negative, and I put the constant as it is and find the derivative of x power 4 using the power rule, which is 4x power 3. So let's simplify this. So we get f prime of x, and this equals 2 times of 2x is 4x, and negative 8 times of 4 is negative 32x cubed. Now we set this up equal to 0, that is the first derivative equals 0. So we replace f prime of x equal to 0. So therefore this becomes 0 equals 4x minus 32x cubed. Now we can solve for this x from this equation. So I factor out 4x, and when I do that, I get 1 minus 8x squared. So this means either 4x equals 0 or 1 minus 8x squared equals 0. So this implies when 4x equals 0, implies x equals 0, or we can add 8x squared to solve this equation, that is 8x squared equals 1, and this implies x squared equals 1 over 8. So we get the value of x by taking square root on both sides. So when you take square root, we get x equals plus or minus root of 1 over 8, that is 1 over root 8, because root 1 is 1. So we get two values, that is x equals 1 over root 8 comma negative 1 over root 8. In fact, we can determine this decimal equivalent. So here we approximate this value to 4 decimal places, and when we do that, we get 0.3536, and the decimal equivalent approximated to 4 decimal places is negative of 0.3536. So basically, we get the critical points as x equal to 0, x equals 0.3536, and negative 0.3536. We will now see how to determine the increasing and decreasing intervals using these critical points. So for that, we have to create a sign chart for the derivative of the function. So I'm going to create a sign chart. So I put the critical numbers, that is this is x equal to 0, and let's say this is negative of 0.3536, and this is, let's say this is x equal to positive 0.3536, and this means we will have uh, this is one open interval, and 2, 3, and 4. So basically we will have 4 open intervals where we have to determine whether the function is increasing or decreasing in these intervals. So the first interval is from negative infinity to negative 0.3536, and the second interval is from negative 0.3536 to 0. The third interval is from 0 to positive 0.3536, and finally the fourth interval is x greater than 0.3536, that is the interval 0.3536 comma infinity. So basically we have to determine whether the function is increasing or decreasing in this interval, and for that we have to prepare the sign chart using the derivative of the function, that is f prime of x. We now see how to prepare the sign chart for the derivative of the function. So here I have copied the derivative of the function which we already worked out. I have copied the factor form of the derivative of the function so that it will be easy for us to determine the sign of the derivative of function in each of the interval. So first let's consider this interval, that is from negative infinity to negative 0.3536. I'm going to consider a random value, that is x equal to negative 1, which lies in this interval. And so we plug this into this first derivative and determine only the sign. So therefore this becomes f prime of negative 1, and this equals 4 times of negative 1 times of 1 minus of 8 times of negative 1 quantity squared. Remember, we only have to determine the sign. We don't need to determine the exact value. So this is 4 times of negative 1 is basically a negative 4. I write down this as negative quantity. And this negative 1 quantity square is positive 1. So 8 times of 1 is 8. We then have 1 minus 8. So 1 minus 8, this is also negative. So we have a product of two negative quantities, that is negative times negative, and this equals positive, which means in this interval the derivative is positive. So I mark positive here, and I also indicate this as like this, that is whenever the derivative is positive, we say that the function is increasing, and when it reaches negative 0.3536, it becomes flat. That is, at this point is the critical point, so we mark this as it is becoming flat. Now let's determine the sign in the second interval. So we pick another random value, that is we can pick say, let's say that we pick negative zero point 0.1, which clearly lies in this interval, that is from negative 0.3536 to 0, and plug it into this and determine the sign. So therefore this becomes f prime of negative zero point 0.1, and this equals 4 times of negative zero point 0.1 multiplied with the 1 minus of 8 times of negative zero point 0.1 quantity square. This is negative zero point 0.1 quantity square. So clearly this is going to be negative, because 4 times of negative zero point 0.1 is negative zero point 0.4. And let's determine this sign. This negative zero point 0.1 quantity square is positive 0.01. And when you multiply this by 8, we get 8 times of zero point 0.01. And this equals zero point 0.08. This is zero point 0.08. And this is a positive quantity. 1 minus of zero point 0.08 is a positive. So we have a product of negative and a positive number, and this means the final result is negative. So the sign of the first derivative is negative here, so we can mark negative over here, that is in this second interval, and we will also indicate the line, the slope, as going downwards, because whenever it is decreasing, whenever the first derivative is negative, we see that the function is decreasing. And once again, it is becoming flat at x equal to 0. And now let's determine the sign at this interval, that is from 0 to 0.3536. So for that, I'm going to take the random x value as x equals zero point 0.1 and determine its sign. So we say that f prime of zero point 0.1, and this equals 4 times of zero point 0.1 multiplied by 1 minus of 8 times of zero point 0.1 quantity squared. So once again, this is going to be a positive quantity now, and multiplied by this is positive, that is 8 times of zero point 0.1 is 0.01, and multiply with 8, we get 0.08. So once again, this is 1 minus of 0.08. This is a positive quantity, so we get positive times positive is once again a positive number. So in this interval, the first derivative is positive, so we can mark positive here and indicate this function as increasing like this. And once again, when it reaches 0.3536, it becomes flat. Now let's determine the sign in the last interval, that is in the fourth interval over here. And now we can take a random x value as x equal to 1 and plug it into the function. So therefore we find f prime of 1, and this equals 4 times of 1 multiplied by 1 minus of 8 times of 1 quantity square. So this is 4 times of 1 is positive, and then 8 times of 1 is negative 8. So it becomes 1 minus 8. This is clearly a negative number. So we get product of positive times negative. So this becomes negative. So the sign of the first derivative is negative over here. So we say that it is negative here and indicate the function that it is decreasing like this. So now that we have prepared the sign chart for the first derivative, we can easily determine the increasing interval, decreasing interval, as well as the relative maxima and minima. So clearly from this sign chart, we know that it is increasing in this interval because it is positive, as well as it is increasing in interval 3. So this is increasing in interval 1, that is from negative infinity to negative 0.36, as well as it is increasing in interval 3, that is from 0 to 0.3536. So we write down this as once again as increasing interval, and also it is decreasing in the interval 2 as well as in 4. So we see that this interval it is decreasing, that is from negative 0.3536 comma 0, and also decreasing in the other interval, that is here also it is decreasing. So we have determined the increasing and decreasing intervals from the sign chart of the first derivative. This means we have answered these two questions, and we will also determine the relative maxima and minima. We can utilize the sign chart to answer these two questions as well. This is the place where we can easily identify whether it is getting a relative maxima or minima. Clearly, this is a maximum point. The function increases, reaches a maximum value, and then it decreases. So this point, negative 0.3536, is the relative maxima of the function. So we write down this as negative of 0.3536. It is the relative maxima, and the relative minima occurs at positive 0.35. I'm sorry, there are two maxima, relative maxima. It is maximum here as well as here. So we can include one more value of x, that is positive 3536. And similarly, we can determine the relative maxima. It is only at this point, that is only at x equals 0. There is a relative minima. Here I show up the final answers to all parts of this question. So we have two increasing intervals, two decreasing intervals, and the relative maxima of f occurs at two values of x, and relative minima occur at x equal to 0.